Okay, as we start chapter 4, this is one of my favorite chapters because it's a lot of chemistry, and it's real chemistry in solution. And what you're going to find is that as we have come out of chapter 2 and 3, where you learned about the math and you learned the foundation for the language of chemistry, nomenclature, is that you really need to know the names and charges on those ions, because in this chapter you're going to see those ions moving around in solution and doing chemistry. And if you don't know the charges and the names, you're not going to be able to use them properly for what we need to do in this chapter. So the bad news is you can't just say, oh man, I failed that test because I didn't know nomenclature. You have to keep working at it so that you don't fail the next one. So as always, on the chapter, you'll see the homework, review questions, review problems, and these definitions are things that you're supposed to have gone through already in preparation for today. So a couple that I'd like to point out in case all of you didn't do that is the first couple of definitions we start with. What is the solute, class? Well, it's not necessarily water. The solute is what is being dissolved. And what's the solvent? Yeah, what it's dissolved in or what's doing the dissolving. Now, for this chapter, because it's aqueous solutions, the solvent is water, but there are other solvents that are not water. And the other that I need to mention, in case you haven't gone ahead and looked at this, is electrolytes and non-electrolytes. When you think of an electrolyte, what do you think of? Gatorade, that's the number one answer. And what does Gatorade have? Salts. Okay, it has salts. It has potassium ions because there's potassium salts in there. So electrolytes, for our chemistry definitions, are things that break into ions when dissolved in water. And because they break into ions, so there are ions swimming around in solution, they conduct electricity. The solution conducts electricity. And non-electrolytes are kind of the opposite. They don't break into ions when they're in solution. They just stay in the molecular form. And when we talk about this, we're going to be talking about ions in solution. And the first thing we're going to look at is metathesis, or double replacement reactions. And when we deal with these, the goal is to get ions out of solution. And there are 3 ways to do that. Does anybody know what they are? Did anyone look at chapter 4 and do this ahead of time, or no? That's exactly what I'm talking about. Okay, do you know what the 3 driving forces are? The 3 ways to reduce the number of ions in solution to make real chemistry happen? Not heating, it's more of the products is what I'm looking for. Sometimes heating does it, but I'm looking for what you make. Okay, if you haven't read the chapter, you wouldn't know this. You make a solid, a weak electrolyte, or a gas. Does that sound familiar from reading? Okay, you wouldn't know this from anywhere else. Okay, this is not something that's typically discussed in introductory chemistry. They talk about double replacement reactions and they say they trade partners, but they don't really push about the 3 driving forces. So the 3 ways you can remove ions from solution are to make a solid, we call that a precipitate, to make a weak electrolyte, often it's water, but it could be a weak acid or a weak base, and to make a gas. So as we start this chapter, you need an understanding of electrolytes and non-electrolytes. And electrolytes are ionic compounds mostly. Some molecular compounds actually are strong electrolytes. We'll look at those on the next page. And these behave differently than non-electrolytes do. When we put a non-electrolyte in water, it just gets surrounded by water. An example of this is ethanol, the drinking alcohol. So we put ethanol in there and we end up with aqueous ethanol, which isn't a surprise. But if we put electrolytes in there, you don't get what you might think. If we put sodium chloride in there, we don't get sodium chloride swimming around in the beaker. What we get is sodium ions and chloride ions. So in this chapter, I'm really going to be talking a lot about your molecule seeing eye, the thing we all wish we had because we love chemistry so much. That if you think about what would your molecule seeing eye see if it looked in the beaker? So we think about sodium chloride, and here I've represented sodium chloride with my little beads, where I'm using the sodium is orange and the chloride is green. And now we think about this. If I dump it in water, what I really see now is this around in my beaker because it breaks apart. So what's in my beaker is sodium ions and chloride ions, not sodium chloride hooked together. So I'm going to talk about that over and over as we go through this chapter about what would you see with your molecule seeing eye, what's really in my beaker. Okay? Calcium chloride does the same kind of thing. Now, calcium chloride is a different formula. So if we think of this as calcium chloride, where I'm going to represent the calcium with the red, and there's 2 chloride ions, what we see when we look in the beaker, again, is not calcium chloride. It's not sitting there all hooked together. We see this. Okay, a calcium ion and 2 chloride ions. And do you understand the difference that these things are breaking apart? So we get calcium ions and chloride ions, 2 of them. Now, in this chapter, it's really important that you start to pay attention to the subscripts representing physical states. So calcium ion is aqueous, the chloride ion is aqueous. We're also going to be writing equations with ions, and that's different than what we've done before. So we now introduce that there are charges on these ions. This is not calcium metal. It's calcium ions, so you have to make sure you write the +2 charge, and because it's dissolved in water, we write the aqueous. Okay, what would you expect to see if I put sodium sulfate in water? Class? 2 sodium ions, and they would be aqueous, plus sulfate. And what you don't see is you don't see sulfur and oxygen. We're not breaking those ions apart. We're just putting the ions in there, breaking them apart, and rearranging them. Okay? So we're not breaking this down into sulfur and oxygen. The sulfate ion stays at one piece. So we're just rearranging the ions that we introduced in Chapter 2. Yes? So with the calcium chloride, it's not diatomic? Right. It is not diatomic. It's not chlorine gas. It's 2 chloride ions. And it's not Cl2, 2-, because that's not the proper formula for a chloride ion. So we have to start thinking about what's really in the beaker. And again, this is where knowing those ions is so important. Remembering the monoatomic ions, the anions that are made out of nonmetals, and those metal ions. Which ones are they? So now, let's have you get with your groups, and on your whiteboards, tell me what do you get when these things go into solution.